Hey there, seventh graders. So today I thought rather than doing a picture of me in front of the board and showing you how to do some of these Punnett square problems, I just take a printout of what's on the website and a piece of notebook paper and try to show you how to do two of them. So I've picked number 5 and 6. Number 5 and 6 both have to do with human Mendelian traits, and they're also kind of right in the middle of the assignment, where the assignment kind of shifts from having to have you show the phenotypes to having you show genotypes down here in the other way that they're worded. So let me just kind of go through these one at a time so you see how they work. Okay, we'll start with number 5. Number 5 says that the trait is cleft chin in humans. So that's the trait that we're looking at. And then it says here that the dominant allele is the capital C, the cleft chin, and the recessive allele is no chin cleft. So that's the lowercase c. And we might as well at this point draw our Punnett square. So here's our Punnett square. Okay, I'm drawing mine way bigger than you need to in your notebook. You can draw yours fairly small, but I just want to make sure that you see how to do this clearly on the video. So the father is homozygous recessive. Remember, homozygous means same. Recessive is the no chin cleft trait. So we're going to put the father across the top. That's generally what we do, but it doesn't have to be. It doesn't really matter where you put each parent. So you have the lowercase c there across the top. The mother is heterozygous. Heterozygous means that you've got one of each allele. One allele on one chromosome, the other allele on the corresponding homologous chromosome. So the mother is capital C, lowercase c. Okay. The first question in this set is, what are the phenotypes of the parents? And this is what you would have in your Google Doc journal, and you're going to be answering that first. Well, the phenotype for the father would be no chin cleft. It's a recessive allele, and the only way you're going to end up with that showing, which is what phenotype means, that's the trait that shows. The only way you're going to end up with that showing is that if you have two of them. So the first one is no chin cleft. That's for the father. And then, comma, the second one, mother, well, she's got one allele for the dominant dominant allele, the dominant type of gene. So she's got the capital C. So then, therefore, she's going to have a chin cleft, and just says that the dominant is cleft. So she's got a chin cleft. Okay, what are the possible genotypes of the offspring? To answer that question, you've got to complete the Punnett square. So we do this, again, just like a multiplication table. I'm drawing the arrows here. You don't have to draw the arrows, but I just want you to see how this goes. So the big C, little c, this one would also be big C, little c, because we go there and there. This one there and there, that would be little c, and this would be little c, little c. So we've got the possible genotypes. Well, we've got this genotype, big C, little c. That's right here and right here. And we've got this genotype, little c, little c. And what's the percent likelihood for each possible genotype? For the first one, big C, little c, you'll see that half of our boxes in the Punnett square have the big C, little c. So 2 of 4, write it down here, 2 of 4 is 50%. So that means that up here, the percent likelihood for that first one is 50%. For this little one, obviously, that's going to be 2 of the 4 boxes for the little c, so that's going to be 50%. Now, I've been saying little c, but what this would be in heredity terms is this would be heterozygous, and this would be homozygous, or this would be hybrid, and this would be purebred recessive. Okay? So what are the possible phenotypes of the offspring? That's the next question in this first set. The possible phenotypes. Remember, phenotype is going to be what shows. So what actually shows up in these potential offspring. So for these 50%, because the dominant allele is present, what's going to show is the dominant allele. And the dominant allele was a cleft chin. So for the first 50%, oh, that should have been 50% there. For the first 50%, that would be cleft. For the other 50%, since this is recessive, the dominant allele is not present, so therefore the recessive allele shows. And the recessive allele, if I look back up here, was that there's no chin cleft. So I'd write no chin cleft for that 50%. What's the percent likelihood for each possible phenotype? Well, in this case, the percentages are going to be the same. 50% show the capital C right here, and 50% show the recessive allele, no chin cleft. So again, it's 50%, 50%. Now what I wrote just now on this paper would be what you would type into your Google Doc journal for the answers for number 5. Okay, number 6 is right here. Number 6 now shifts to actually just saying the problem in sentences rather than giving you all of the variables right away. So I'll turn my notebook page and I'll read it for you. In Caucasian humans, so this is a trait that previous books always said in humans, but we found now that this isn't true for African Americans and for some other groups. But in Caucasians anyway, a widow's peak hairline, capital W, is dominant to straight hair. Okay, now this is asking you to think a little bit. We're going to have to write down what the dominant is. So dominant is going to be the capital W, and that's widow's peak. So in this, because it's just given as a sentence, we're kind of reconstructing in our notes what it said here for the previous type of questions. Okay, in Caucasians, the widow's peak is dominant to straight hair. That means then that the recessive is going to be straight hair. And if you remember from the video from the other day, I said that our rule in heredity is that you put the lowercase letter for the recessive. So the lowercase letter would be like a small w. I tried to make those very different looking. The question now goes on to say, cross a heterozygous widow's peak hairline male. Okay, heterozygous widow's peak hairline. Well, heterozygous means one of each. So here's the male, the father. Bring that up. Father. And he's heterozygous. Heterozygous means he's got one of each allele. Capital W, small w. And we know now that since the dominant allele is present, the phenotype for that father is going to be widow's peak. Oh, no E in peak. Widow's peak. And then it says with a straight hairline female. Well, the only way that a female, a Caucasian female, can have a straight hairline is to have this recessive allele right here. So that means that the female, or the mother, is going to have the recessive allele. And of course, the only way a recessive allele shows is if there's two of them. So that's the genotype for the mother. And she has straight hair. Okay, so in reading the question, I had to kind of come up with this information that was just shown in the first five. Now I've got to work my Punnet square. So I'm going to work my Punnet square before I even read anything else, because I know I'm going to need this for the problem. So here's my Punnet square. I can draw it a little bit smaller because I know you guys know how to do it now. And I'm going to put the father across the top. So there's the capital W, goes above that square, and the lowercase w goes above that square. And then I'm going to do the mother on the left-hand side, lowercase w there, and then lowercase w there. Okay, so I've put the mother's genotype in and the father's genotype in, and now I run the Punnet square. I just run it like a multiplication table, there and there and there and there, little, and then down here, there and there and there and there. So what's interesting about this problem is that the results came out pretty similar to the previous problem. So again, we're kind of seeing 50-50 as we look at the Punnet square. So I'm going to go back to the questions now. And it said, what are the genotypes of each parent? Well, we figured that out here. The genotypes of the father is going to be capital W, lowercase w, or you could also say that that's hybrid, or you could say it's heterozygous. For the mother, we've got small w, or you could call that homozygous recessive, or you could call it purebred recessive. What are the possible genotypes of the offspring? Oh, and I do want to point out that in this question, this says genotypes here, whereas previously it said phenotypes for the first five. So it's kind of shifted. The first question now is what's the genotypes, because it's already given you the phenotypes up here. What are the possible genotypes of the offspring? Well, lo and behold, when we look at our Punnet square, here's the possible genotypes of the offspring. And we have the same possible genotypes for the offspring as we had for mom and dad. So we can write those in. Capital W, lowercase lowercase, or heterozygous and homozygous recessive. What's the percent likelihood for each possible genotype? Well, again, looking at our Punnet square, we see that 2 of the 4 squares are the heterozygous, and 2 of the 4 squares are the homozygous. So again, we've got 50-50. Okay? What are the possible phenotypes of the offspring? Well, it's going to be the same as mom and dad. So the phenotypes, again, were this one is widow's peak, and this one is straight. And what's the percent likelihood for each possible phenotype? Well, once again, going back to the Punnet square, 50-50. So I'm just going to say 50% widow's peak, 50% straight. I want to make sure you see why that was 50-50 again. This was 50-50 widow's peak because in these two, the dominant allele is present. So that's going to be what shows. In these two, there was no dominant allele, so the recessive allele is going to show. And that's what we're dealing with when we talk about phenotypes. Now, in these two problems, we happened to get 50%. But in another problem, you might not get 50%. So don't think all of these are 50-50 problems. Let me show you an example of that. So if you had a problem, like let's say that instead of this, you had a problem where you had a man that had, say, 2 dominant alleles in his genotype, and you had a woman who had a dominant and a recessive, so was heterozygous. Now in this case, you'd end up with not just 50-50. Now here what you'll see is that 50% of the genotypes are this. 50% of the genotypes are that. But for phenotypes, because there is a dominant allele in all 4 of those, 100% of the offspring are going to have a widow's peak. Okay? So don't think everything's 50-50. Don't make that mistake. Or if you had a problem that was like this, where you had 2 individuals that had heterozygous genotypes with widow's peaks. So they both had widow's peaks, but they were heterozygous or hybrid, meaning that they each had the allele for straight hair in their genotypes, but they didn't show that. Their phenotype was widow peak. If you run that Punnet square, you'll see that we don't get 50-50 here either. We get, for genotypes, we get, of the homozygous dominant, we get 25%, 1 out of 4. For this one, for the heterozygous combination, we get 2 of the 4 squares, so we get 50%. For this combination, the homozygous recessive, we get 25%, 1 of the 4 squares. Now take a look closely at that. How many percent would have the widow's peak? Well, this 25% would because there is a dominant allele present. This 50% would because there is a dominant allele present. So 75% of the offspring should have a widow's peak. Or we could say it this way, there's a 75% chance that they'll have an offspring with a widow's peak. But there's only a 25% chance that they'll have an offspring with a straight hair. So I just wanted to show you those other examples. This first example was the problem right here. And I put those answers down on the paper. But those other 2 Punnet squares I just drew were to show you that everything isn't 50-50. So I don't want you to get that idea. But I do want you to see how to actually work these problems and then what you should be writing in your Google Doc journals. All right, this has been a longer video than I thought it would be, but hopefully that's been helpful. Good luck on your work, and I look forward to seeing those in your Google Doc journal on Tuesday. I won't be posting anything new on Tuesday. Notice that I have given you a reading assignment that will be due next Wednesday, and so you can work on that over the course of this weekend if you'd like to. Otherwise, you should be able to do some of that today, and you should be able to do some of that on Tuesday, so you can have it done on Wednesday. All right, have a great weekend, and I'll talk to you all next week during a group meeting. We will not have a group meeting this week. Bye-bye.